Okay, so this is problem 39 of chapter 18 of Giancoli 6th edition. So we have a power station that delivers 620 kilowatts. So let me put here the power of this power station is 620 kilowatts. And it delivers this amount of power at a potential difference of 12,000 volts. Okay, and delivers this to a factory through wires, very long wires, with a total resistance of 3 ohms. So these wires are very long, connecting this power station with a factory somewhere. They're very long, but still they always have some resistance, even if it's small. Okay, and we want to know how much less power is wasted if the electricity is delivered at a different potential difference, at a much bigger potential difference, a potential difference, I'll call it the new one, of 15,000 volts. Okay, nothing else here changed. The power generated is always the same, and the resistance of the wires remains the same. But we want to know how much less how much less power is wasted if the electricity is delivered at this bigger potential difference. Okay, so let's start with the original case on the left, and from P and V we can find the current created by this power station. Now, so we have that the power is IV. So from here we can get this current. Once we have this current, we can then find out how much power is dissipated through the wires. And so the amount of power dissipated through the wires we know is going to be given by I squared. We just found that I squared multiplied by R. Okay, so what is the idea? We have here a power station that generates power, electricity, 620 kilowatts, and then it's going to send through this wire all the way to a factory. Some will send this power to this factory, but through this wire here, part of this energy will be lost, will be dissipated. Okay, so if I put all these numbers here, I will see that I get around 8,008 watts is dissipated, is lost. Okay, let's try to do now the same exercise, but instead of just 12,000 volts, let me increase this potential difference much more and use now 15,000. What is going to happen now? Well, if I use the same equation, that power is IV, for this new I will find a new, for this new potential difference, I will find a new current. And what do you expect? This new current will be much smaller, right? Since this current is the potential the power, which does not change, divided by the potential difference, which is now much larger. So my current will become much smaller, and this is good because with the issue now is that I will dissipate much less, right? Because the power dissipated is that current nu squared over R. Since I is now much smaller, I will get much less power dissipated. If you do this calculation, you will find 461 watts, so much less. And so what is the difference? Well, now we just need to subtract these two. The old one, so this difference will be the old one, 8,008 watts, minus the new one, much smaller, 461. Okay, so that's the end of this problem, and this number, of course, will be given in watts.